suppose you have two different functions. You have x equals pt and y equals qt. Okay, so let's say x equals, I don't know, 3 plus t and y equals 3t. Okay, those are just two examples of functions that look like that. They are essentially a pair, x and then y, and they make what's known as parametric equations. Now, what you can do is you can combine those parametrics into what's known as a Cartesian. So a Cartesian equation is your standard y equals fx. Okay, now the domain of fx is the same as the range of pt, and then the range of fx is the range of qt. That you have to know because they're gonna ask you questions. They're gonna ask you to put something in Cartesian form, and then they're gonna ask for the domain and range. Okay, but that is parametrics. So let's go through an example just to explain it a bit further. So a curve has parametric equations x equals 2t and y equals t squared. And then they've given the range of values for t. Find a Cartesian equation of the curve in the form y equals fx. Okay, so essentially what we need to do is we need to make t the subject of one of them in order to substitute it in. What we've got is essentially a simultaneous equation. So if we make t the subject here, we can now substitute that there. So that means x squared over 4 is our Cartesian equation. That's it. Okay, state the domain and range of fx. Now, the domain of fx is the range of the x parametric. The way we work out the range of the x parametric is by substituting in -3 and 3. Like this. So, the domain of fx is -6 x 6, like that. And then the same essentially goes for the range of fx. And I'm just blowing my nose. Resume. And the same goes for the range of fx. So if we sub in -3 as t, we get 9. And if we sub in 3 as t, we get 9. But if we subbed in, let's say, -2, we get 4. If we subbed in -1, we get 1. If we subbed in 0, we get 0. The same numbers we would get with +1 and +2. So the range is really from 0 to 9. Like that. Range of fx. Okay. Sketch the curve with the given domain for t. So we've got the domain being from -6 to 6. We've got the range being from 0 to 9. And then we have x squared here, which means it's a quadratic. And it's a positive quadratic. So if we were to draw it, it would look something like this, where this point is -6, that's 6, and that's 9. And the way you would write the equation, instead of writing the Cartesian next to the graph, you would write the parametric. Like that. Okay? And there you go. That is parametrics. So, I've put up 3 questions which I want you to try, please. Okay, for the first one, we want to find the Cartesian for each parametric. For the first one, we can rearrange like this to make t the subject. And now we substitute that to get x squared plus 4x plus 4 plus 1. So x squared plus 4x plus 5. Okay, now it's a matter of finding the domain and range. To get the domain of our Cartesian, we sub in -4 and 4 into the x parametric. So, like this, and like that. So this will give us -6 and 6, and that is your, sorry, no, not 6, 2. There, that would be your domain. So -6, x, 2. Okay, the next one, for the range, you're going to do the same thing, except you're going to plug it into the y parametric. So y equals -4 all squared plus 1 and 4 all squared plus 1. In either case, you get 17. But if you sub in 0, you get 1, which is your minimum value. So the range looks like this. Done. That's part A. Part D. Again, we need to substitute in or find a substitute for t. So x minus 1 equals 2t. X minus 1 all over 2 is t. Y equals 1 over all of that. So 2 over x minus 1. There you go. For your domain, it just says t is greater than 0. So if you sub in 0 into your x parametric, so 2 times 0 plus 1, you get just 1. So anything greater than 1 is your domain. And then for the range, again, you sub in 0. 1 over 0 gives no solution. So you assume greater than 0. Okay, last one. Same thing again. You're going to do, so you have x equals 1 over t plus 1. If you take the t plus 1 to the other side and then divide by x, you get this. That is your substitute. And then when you put that in, you get 1 over x minus 1 minus 2. There's your substitute. When you simplify that, you end up with 1 over x minus 3. Then you can times everything in the denominator by x. So you can make it like that. So if I just considered this as the denominator, you would then get this. And now, when you flip it, you get that. That is your Cartesian. The range of values for t is anything greater than 2. Okay, so when you substitute t equals 2 into your x parametric, you get a third. And then for the range, when you sub in t equals 2 into y equals 1 over t minus 2, you get 1 over 0, which gives no solution. So your range is y equals 0. And there you go. That is parametrics, converting to Cartesians, and then domain and range.